All right. Hi, everyone. Welcome to TypeScript for Swift developers. The first question on your mind should be, wait, why is this even in the conference, huh? Um, so, in part, I have a very long history with NSSpain. I was there for the first NSSpain. NSSpain is one of the few conferences I have ever paid for and attended. And in part, that was because sort of at the cusp of the time period when we were trying to create the project CocoaPods, NSSpain was kind of like this conference that just kept being at the right place at the right time. And so I love the conference. I'm a big fan. I loved going to Logroño and like hanging out with the organizers and all of the other like cool Spanish folk. Um, and so I thought it would be interesting to try and take sort of the stuff that I do nowadays and try and like reapply it back to like what it would have been like for me back when I was starting to get introduced to the concept of JavaScript. So you may or may not recognize me by name. My name's Orta therox. I've worked off and on CocoaPods for about 10 years. Since then, I've worked on a project called Danger too that runs in like in Swift, Kotlin, JavaScript, Ruby, and Python. And nowadays, I spend a very large amount of my time working on TypeScript. I work on the compiler team for TypeScript, which generally where I generally focus on like user-facing stuff like websites, sort of processes for contributing to very large repos and things like that. And it's super interesting work. And we'll sort of talk. This talk is mainly about TypeScript, which is shocking. But the interesting thing here is like, do you need to know much about TypeScript as a mobile developer? I mean, not really. Like if you're doing React Native, yeah, sure, but like that's a whole different ball game. I think though, like some of the value in understanding like TypeScript is going to be in like understanding what other programming ecosystems are doing, what people like about other programming ecosystems, and trying to get an understanding of like a lens on Swift and Objective C through a JavaScripty lens, and like TypeScript, as we'll go through in a bit, like is in a really interesting position as a programming language. And one, it's like it's working with JavaScript, and JavaScript is not one of the best loved languages in the world. But TypeScript is the second most loved language on Stack Overflow's user survey. This isn't like a bunch of people who explicitly are TypeScript users. This is like general programmers. TypeScript came in second. And that should say something, right? Like people love this programming language, so let's try and dig into what makes TypeScript unique, and how that reflects on the languages you use every day. So TypeScript, its goal is to sort of have this level of JavaScript interop that's practically seamless. JavaScript is the world's most popular programming language, originally built for doing small scripts, and then nowadays it powers like obscenely large applications. Many millions of lines of code of JavaScript, and like the language has evolved, but not drastically. But one thing it doesn't do is have a static type system. So it has types, but it doesn't necessarily have a way to declare like the only input to this thing is this one thing, the only output from this thing is another thing, and realistically, you need a type system when you start hitting certain scales of code bases. Like it's an interesting thought experiment. I had to cut this from the talk, but if you look at old Objective-C, like anytime you see parens and a type in there, that's entirely optional. You could just delete those parens, and you'd find that the code actually does still compile. It's just typeless. And so old Objective-C used to be a lot like JavaScript, and modern Objective-C is a lot more like TypeScript, where you're adding these optional types in all these places that you don't have to add them. TypeScript aims to have every feature of JavaScript inside it, which is a little bit meta, but it's part of how the programming language is pitched. It's that like it is JavaScript with types. That's it. it takes all of the same like baggage of JavaScript and still brings it over. But it also adds, the ability to say, this is what an input looks like, this is what an output looks like. And it also has a kind of crazy type system, like almost infeasible to imagine after having used normal programming languages all your life. In part because some constraints, like it needs to be erasable, which we'll see in a second. One metaphor for thinking about this is like, when Swift came out, it did actually support pretty much every feature of Objective-C, because it had to in order to support all of the like Objective-C libraries that Apple had built over the last 20, 30 years. And so the similar metaphor here you can consider with the @Objective-C tag and things like that in Swift. So TypeScript's main goal is to go from this code on the left to the code on the right, wherein you could declare an interface very similar, and you could say that the say hello function takes a user, but that doesn't run in a runtime. So TypeScript's goal is to get rid of all of the parts that make it TypeScript to make itself JavaScript, which is a pretty wild concept. And that's generally like a source code to source code compilation, not necessarily a source code to runtime compilation like you see in sort of Objective-C and Swift. Because of how TypeScript works, TypeScript powers all of the JavaScript tooling in pretty much every developer IDE at this point. So if you're doing JavaScript at all, unless you're doing it in Xcode, although when Xcode gets LSP support, they'll probably use TypeScript too. Even Nova supports this. Anytime you're using JavaScript, that's basically the TypeScript compiler running under the hood, just thinking, okay, I need to be in the loosest mode possible to support the weirdest types of code, and I'll do a huge amount of inference in that. And so TypeScript's user base is this obscenely large number of JavaScript users, and then it sort of narrows down to this sort of this version of TypeScript that's stricter than the normal version. It's a bit like turning on errors as warnings. Okay. And so that's actually the end of like my talky talk bit. We're going to do the rest of it in the playground. So let's get this set up. Right, so this is the TypeScript Playground. The TypeScript Playground is a website. It's a lot like the Swift Playground, but TypeScript. The TypeScript compiler is made in TypeScript, so it can run in a web browser. So this is just like the actual compiler running. And so I can't do A equals B, for example, and all the autocomplete. Or I can do that? Weird. In either case, it's got all the sort of like interesting functions. The things that we'll be looking at is this JS, which is what is the JavaScript equivalent of the code that you've wrote. So right now they're the exact same. I'll make that a little bit bigger. But if I say declared that this is a string, very similar to Swift, and you see that it is removed from here, it's not there. So this is the TypeScript, this is the JavaScript. We'll probably never show it, but this is the DTS, which is a lot like a header file in Objective-C. Because it's kind of a web project, I made a plugin infrastructure for this website. So we're actually going to be using a plugin that I made for doing this talk in order to sort of quickly jump through the sort of sections of code that we want to go for. So let's take a direct look at Swift versus Objective-C, Swift versus TypeScript. So this is what it looks like to declare a class, and this is what it looks like to declare a class in JavaScript. They are it keeps a lot of the same JavaScript. Not much different there. Very, very syntactically similar. As the equivalent of a struct there isn't a direct metaphor, but there is a sort of we just call it. There's just like object literals. They're just everywhere. They have like similar-ish mutability rules, and they do copy and write under the hood too. There's functions, again, very similar. Like the biggest difference is a capital S versus a lowercase s, and a arrow instead of a colon. Other than that, you could copy and paste between each other very trivially. TypeScript has protocols and interfaces. They're more like Objective-C interfaces rather than Swift sort of, extend, they can extend things and add functions depending on their sort of internals. None of this is available in TypeScript because TypeScript cannot affect the runtime of your JavaScript code. So you couldn't make an interface that can affect the sort of the code that is emitted at the end. So all of this, anything like this has to be completely erased in order to run in a JavaScript runtime. So as you can see here, it is just nothing in the JavaScript version. There is two ways to define almost the same syntax. So both of these are the exact same. They both have a must be settable and a does not need to be settable. So something read write and something read only. It's very confusing for newbies. We have some documentation on what the differences are. But I think from this point on, we'll probably never use interface. We'll just always use types. Like, think of it as like interface has a higher complexity, has a lower complexity ceiling. Type allows you to do all sorts of wild stuff, whereas interfaces generally don't. Next up, we have a general example of what it looks like to try and think about type versus runtime code. So if we looked at this code in Swift, you have a definition of a struct, you have a function, and then you have some sort of code that sort of sets up and uses both of those things. Now, when you think about this, there are parts of this that are here to tell the compiler what all these pieces are and how they all connect. And you could conceivably imagine that, like, at runtime, this struct is not there. At runtime, this reference to a person is not there either, because it's a set of evaluated scripts that just go from top to bottom. And like, I realize that it's flattened, but there are still like concepts like functions that jump to different registry points or whatever. And so like this is basically the equivalent of what the TypeScript compiler is doing on the hood. So this is the exact same version of that same code. Like, again, you can barely tell the difference. It changed the word struct to type, got rid of that arrow, changed that arrow to the colon. And so when you look at the JavaScript emit, you can see it's exactly what I just described. It tries to erase all the type stuff and just leave the sort of runtime stuff. And so like you can kind of think of JavaScript as a runtime for TypeScript. It's a little complicated, but it's an acceptable simplification. Okay, cool. So we'll look at a few like interesting language features here, and I think one of the first ones that really surprised me is that you can build the entire type system, roughly, let's call it 70% of the type system, in comments. So this is like some code that I took from Alamo Fire. It's just some Swift code that says, there's a parameter, authenticator, credential, and refresh window, and they just match the function. Like some of this is just bad comments, but the important bit here is like this, when you write like pretty serious production code, you pretty much will always do something like this. And so TypeScript has the exact same thing where you would just do a param, and then you say the name of it, and then you copy and paste the word the authenticator type 3 times. Except here you actually also include the type. Now this is normal JavaScript code, and remember how I said that TypeScript has to support all these JavaScript users? Well, if a JavaScript user writes this, we take these comments and we turn that into the type system. And so you would get type checking that this parameter authenticator type for this parameter authenticator is the type authenticator type inside your JavaScript code. So all of this like really complicated type system can actually entirely live almost entirely in comments, which is pretty wild. You have some really strange, you have to write some really strange code at different places to make that work, but it works. And there are like non-trivial projects using it, like the Chrome, like in fact, the team that made this sort of inspector, let's see, yeah, whatever, it's on a different screen. this thing. This thing was originally wrote in JavaScript, and then it got redone with this type system, and then came back, and then came to TypeScript after that. So it's like this nice incremental way to migrate, a bit like having Swift and Objective-C in the same code base. Next up. Okay. Next up is about how the type system thinks about itself, which is complicated. This code in Swift would just not fly, right? Like we have a struct resolution and a struct rectangle. We create a resolution and we create a rectangle, and we cannot set a rectangle to be a resolution and a resolution to be a rectangle because they're different types, right? Like they have a different name at the end of the day. We call these nominal types. Every single type is its own sort of unique namespace, unique identifier in the global namespace. Whereas TypeScript actually has a different approach to this. So this is like with real compiler warnings, I think. Yep. TypeScript only defines the shapes of objects. And so the way in which these descriptions work is that TypeScript only cares about whether they are structurally the same. So it checks, okay, is there a width and is there a height? It doesn't check, is the type resolution, is the type rectangle? So this is actually like more computationally expensive, right? It's much cheaper to just say, oh, does the name match? Which is probably somewhat what happens under the hood in Objective-C and Swift. But in this case, we actually have to check every single property of every single field and the value and the keys to see whether they are the same, which is quite expensive. But you can get a sense of why over here in the JavaScript, right? There's like, it just creates an A and it creates a B and it allows them to be assignable between them. To JavaScript, there really is no difference between these two lines of code. And so TypeScript has to sort of emulate that entire runtime behavior, but inside the compiler itself when it's trying to decide whether something is like assignable between each other. So that's called a structural type system. Like you may have heard of like Ruby's duck typing system. It's a bit like that, but like this has to be verified formally. Whereas duck typing is generally just the case of you do a dot and it just does whatever it says after the dot. This is a rich type system. Cool. That's pretty interesting. What I found very interesting about the first time that I started playing with this is that like that structural type system doesn't necessarily, it can be submatching, like matching on a subset. So this rectangle here is the parameter to this function. And you can pass in an object that is bigger than the sort of the interface. So this is a lot like Objective-C, right? Like you say it's an interfaceable, right? And so all it matters is that the width and height is in there. But in TypeScript, depending on where you put the description, so in this case I said this bounds is a rectangle here, oops, then you actually started getting type errors. So when the code looked like this, like the runtime is the exact same. But now that I added that type definition right there, then it actually changes the sort of mechanics of how TypeScript looks at something. And so like types and interface don't necessarily act exactly like protocols in Objective-C and Swift, but they are somewhere between like a real type and an interface, kind of depending on how you assign the connection between the object and the type. So that was a pretty wild one. That took me a bit to learn when I first started doing it. Okay, so next up is one of my favorite features from TypeScript. So this is the Swift definition of a string that's static, that's doesn't change. That's a login message. This is the same code in TypeScript. Actually no major difference there. The syntax could almost be the exact same, but it's actually wrong. Like let in TypeScript is mutable, so let is var and const is let. So this is where the interesting part is. We've just switched from an immutable, like a mutable version of a definition to a mutable version of a definition. And now when I hover over login message, it actually says that the string type is welcome danger. And this is what this is why it starts getting really interesting. So you can declare that an exact match of a string is a type. So string as a concept, accounts for every single possible character combination. This type is only one possible character combination: welcome, comma, danger. With capitals and stuff like that taken into account. And like this means that you can sort of describe really interesting like behavior. So this is a type that, for example, like this, you can imagine the protocol where name can only ever be the string rectangle, and the width and the height can be any number that they want. And this is pretty cool. So this means that you can sort of describe a bunch of objects by sort of saying that this exact string and then this combination of stuff. So, for example, here I tried to make another rectangle, but it was a square because let's make those match. There we go. Because the width and the height are the same, so it's it's reasonable to call that square. But the TypeScript system is like, nope, it has to be called rectangle, that string. And so we call these literal types. So it's like you have every possible string, and then you have a tiny subset of that, infinitesimally tiny, which just says that one exact string is exactly what that type is. And they do the same for numbers too. Where this is used is in like APIs and stuff like that. So we've got this function here. It says that the only thing you can call on this function is /API/artworks. That's it. If you call anything else, then you get a compiler error. And like this can allow you to sort of do some really interesting things once we mix it with the next language feature we're going to talk about. But note, like, you're getting autocomplete for this this exact string. That's kind of cool. So the next thing that we're going to look at is unions. And this sort of is a way of describing maybe this type or maybe this type. And like, these are not super foreign ideas. We'll cover them in a second, but they're like something similar in Swift. But now you can get a sense of like, okay, so the first example wasn't very useful at all. But the second one is, right? Like, now you could hard code a list of every possible API route in your API client, and when someone uses it, someone never needs to go out of their way to go and find out what the list is. They can just start typing, and it'll automatically do that, and it will check the code that it fits. So this is super cool. This is and again, like, features like this are done to support existing JavaScript code, right? Like, there is billions of lines of JavaScript out there because it's like infinitely backwards compatible. And TypeScript has to sort of find a way to work with all that code because no one, you can't port that much code to TypeScript. And, who's going to port jQuery to TypeScript? And so TypeScript has to have ways to describe how people use sort of constants in this sort of way. So, this would generally then look, someone would normally write something like this, where instead of directly writing the code like that, they would just give it a name. And so now this type API paths looks like this. The feature is called a type alias, which is very similar to Swift's type alias. And so you should have a sense of what it looks like for that renaming. But the idea of unions is what we'll look at. So, this could be this or that, right? It could be /artworks or /artists. And this concept is actually not that similar to nullability in Swift, right? Like, this name here is a string or it is not a string, right? It's either nil or a string, depending on whether an environment variable has been set. And so you can get the sense of like, there's a way to describe like multiple values of the same object simultaneously. And another way to think about that is like enums also act like unions, especially once you start getting quite close to how you how you would generally sort of split between these enums. So thinking about this, you could totally see these as all being different API cases in an enum, like API responses in the enum. Admittedly, you don't have the constants, so like this can only ever be 404, this can only ever be 41, this can only be 200. You would typically write something like this, like an enum that's like API response, and then you'd have a switch case that would switch through all the different types of enums, and then you'd sort of extract out useful information. Well, in this case, because all of this has to have no runtime impact, right? All of this has to be directly deletable. TypeScript has to basically sort of work around not being able to add rich support for enums with attached types and stuff like that. And so what you get is this API response here says that it's one of these three types. You pass that in, and then it does a switch on the status. So it maps through each of those types and says what is the status, and then it says it could be 200, 401, or 44. And you can't have typos there. You can't add a new one. Well, if you can't, like, you get errors if you add if you put new things in. All super cool, super useful, and very pragmatic way to sort of deal with existing code and try to work around it work around how people work. I'm a big fan of these. Enums are a really cool language feature that I think they get a lot of work done. All right. So when Swift first came out, it was probably my first introduction to generics, and so I was like, that's a funky idea. That it's still a funky idea, but it's certainly not as it's certainly not as expensive in my head as it used to be. So we got an example here of like a struct and then a sort of response that takes another struct. If you've never used generics before, they're basically like arguments for types. And you can see here, we create an artwork and then we create a response success with an artwork. Maybe that could be inferred in Swift. It probably could. I don't know. I didn't test it. And then we can have the exact same code in JavaScript where we have an artwork, we have a type, it takes in a body type, and we create a name base for the two, and then you've got an example of that working there. Very simple-ish, kind of normal stuff. And what we'll do is we'll try and make a little HTTP client that uses a little bit of generics in a way that's kind of unique to how TypeScript works. So we want to sort of do a HTTP client that emulates REST. If you've never done REST before, that's basically like a sort of generally standard way to think about how to edit objects over the internet. There's a way to read it. There's a way to sort of edit it. There's a way to, I don't know what the S means, create one. There's a way to delete it. S&T, representational entities, state transfer. I can't remember anymore. But roughly you have one that gets all of the information, one that can send a little bit of information but not the ID, then one that partially can edit any single field, and then one that just takes an ID. And TypeScript can describe all of this in types, not necessarily by you hard coding everything. So for the artwork get case, it would just be, we have an artwork and we just say, that's the thing that gets returned. But when we can start getting some interesting TypeScript, bad me with bad code sample. We can start getting something a little bit more complicated here, right? For the post, you do not know the ID of an artwork because you're creating one. So you take this object, this type artwork, and you just use a thing called an omit, which is what is it? It's a globally available type that has some sort of funky code under the hood that removes it. So ID is removed from artwork in artwork post here. That's all that this does. I could also I could remove title, for example. It's not an array. It's a union, and now it's just artists. And so with TypeScript, you have this sort of type manipulation system, which is also pretty wild. And then it gets a little bit wilder. This version is the partial, right? So this is patch. You only send just title and the ID, or just artist. So we have a way of saying for every single property in that existing type, do this thing. So this partial version of the artwork is always going to be maybe an ID, maybe a title, maybe an artist, and it's either going to be string or it's going to be undefined. So we've sort of manipulated and made a pipeline for generating partial versions of existing objects. And this isn't actually accurate, so we do need to use another thing. So ID is always going to be there. It has to be there, otherwise it doesn't know what object to update. So this actually now it uses an intersection type and merges these two types together. So if a union is an or, then the and is a jam them together. And so this artwork version now is a partial version of the original artwork, so everything is optional. We saw that earlier. And it's a merged version of ID. So I can do params dot, and I've got a question mark on my artist here, but I've not got a question mark on my ID, and I do have a question mark there. So that's some pretty interesting type manipulation. These are this sort of concept isn't usually this is a functional programming language concept, not necessarily a sort of get things done programming language concept. And so it's kind of cool to see them in real life. And so you can sort of combine all of that stuff together. And so this is an artwork here, and then this type here, well, it is a generic type that reapplies all of those concepts we've just learned and then generates a sort of HTTP client just for that single artwork. So, it's got a get, and that get returns the original type. It's got a post, and that post takes that original type in the generic and removes ID. So I would be able to do post.title, but never post.id. The patch does a partial of the type. That's the shortcut. I did the long way in that code sample. And then it makes sure that ID is in there, and then delete just is an ID. So I could do client now.delete.id. I could do client.get. Any of these things, because it should contain the full object. I could do .patch, where I have a question mark on my artist and a question mark on title, but nothing on ID. And all of this is done entirely in the type system. There is no code in this code sample. This declare here is just a lot like I don't know, it's like defining. I don't even know if there's an equivalent in Swift and Objective-C. It's just a way of declining a global variable. This is so I don't have to write out the entire object. And so TypeScript provides all these interesting sort of pipeline-y systems that allow you to do all sorts of interesting work. And then one last thing before we start to wrap up. There is, if we create a type for this, right? We have a bit of a tension, right? Where I would like to be able to sort of pull out a part of a type. So I've created this, cool, somewhat complicated HTTP client, but then when I want to declare, a function with its arguments, I need to find a way to sort of pull out parts of that in order to reuse them. So TypeScript supports, using these square brackets to sort of dig into an existing type to create a new one. So I could say, get or pat post here, and it's pulled out just this part. And it said this bit here is the type that this function is interested in. So if I added a new thing here, that's automatically going to be involved in here. You can see there's my FCFS. And so there's tons of really interesting, complicated types only features in TypeScript that are somewhat unique to the domain of the TypeScript has to be complete. The type system has to be completely erasable. And a lot of this fixes all of these kind of common problems that are that you get in JavaScript code bases that solve problems in unique and interesting ways. And that's what I think is cool about TypeScript. it is backwards compatible with roughly 25 years of JavaScript. It only adds types and new syntax in specific places in this code base. So like, you know where you can add a type and where you can't, and so does a compiler because it has to erase it. And TypeScript itself can never add new features. Like, let's say we thought it made sense to add a pipeline operator where you could do, something like this. I don't know, post then some data. Hello. Like TypeScript, the programming language, has like a strong design rule that it cannot add new features to JavaScript. So stuff that goes into the runtime. So we work with the JavaScript committee to get those kind of features in, but that has to be infinitely backwards compatible too. And e.g., it can't break the old web. And it's kind of on the TypeScript team to sort of help implement those ideas at JavaScript level, then implement them into TypeScript language. And TypeScript has to sort of only innovate in the type system. So that's an overview of the language. It covers quite a lot of cases that should like give you a sense that like, if you have to touch TypeScript or JavaScript code, it's somewhat familiar, and two, it's really, really interesting. And so hopefully next time, someone says to you, maybe you'll be writing JavaScript, you maybe won't feel so scared, intimidated, and afraid of how like wild and gnarly JavaScript is. It's a massive ecosystem, so a lot of people doing really wild things, but generally speaking, most people are using TypeScript now, and it really does like bring a lot of constraint to the language that makes it much more easier to use if you come from like a stricter type system background. So that was me. I'm Orta. Sorry I took a little bit longer than I took, but hey, this original version of the talk ended up being like 45 minutes. This is like the third recording. All right. Ciao, folks. Bye.